Hello, fourth grade. This is Miss Bruin in the virtual science lab. And during this lesson, we are going to be looking at different kinds of wave patterns. We're going to be exploring sound waves, looking back at light waves, and talking about waves that are a little bit more complicated than both sound and light waves. And you see them in the illustration here. They're called radio waves. We're going to reflect on different devices engineers have created that we use in our everyday lives to transmit light and sound across long distances. Let's start by thinking about some of the signaling devices that you've encountered in your life. What does each one communicate? There are some examples here, but I want you to think about your own lives. What devices have you experienced or have you used that give off some kind of a message through light patterns or sound patterns? Make sure to jot down each device you can think of and the type of message it sends. What does it communicate? You might also even jot down how it communicates. Does it communicate through light or sound or a combination of both? Make sure you jot it down in your slides, in your science notebook if you keep one, or just on a piece of paper so that you can snap a picture and turn it into your teacher. Now, scientists, we are going to think about some of the devices, some of the signaling devices that maybe we've seen in our lives or we've seen in the movies, but they're devices that people use to send messages using sound patterns, light patterns, or maybe even radio waves. So, we're going to play a game that's going to help us do that called sound waves, light waves, or radio waves. Are you ready? It's going to be up to you to think about whether that device uses sound energy, light energy, or radio wave. Now, it might feel easy to identify the energy or the waves that some of these devices send out, but radio waves are a little bit more complicated because radio waves are part of that invisible energy spectrum. So we can't quite see radio waves. And a lot of the time, we can't find evidence of radio waves. So good luck to you. And it's okay if you're not sure. We will talk more about radio waves after this. Let's take a look at our first device, the telegraph. And here is your second device, the lighthouse, sending a message to the ships out at sea. The third device we're looking at is the traffic light. Think about how this device sends signals. It's sending signals to cars and traffic all the time, letting them know when it's safe to go, letting them know when they need to stop. And here we have the two-way radio, also known as the walkie-talkie. It will take something you say and somehow transfer it to another person in another location that's also using a walkie-talkie. The last device we'll be looking at together is the cell phone. On the cell phone, you speak to somebody using your voice, and somebody, no matter how far away, can hear what you're saying. What an incredible invention. But how does it work? Now that you've seen an example of each of these devices, or you've heard how they work, it's going to be up to you to use the table in your slideshow or set up a table in your notebook or on a piece of paper so that you can show which type of wave is used by each signaling device. As you look at how each device works, ask yourself, do I hear anything? Do I see light? Or is it something that's a little bit more mysterious that I can't figure out exactly? If so, it might be radio waves. We'll talk more about that in just a second. You're probably sick of listening to me talk about waves, but this whole lesson is all about using different kinds of wave patterns to communicate messages and to transfer information. Now, we use these devices every single day, but if you're like me, you've probably wondered at least once or twice, how do cell phones really work? Whether it's a walkie talkie or a cell phone, they work pretty similarly. It all starts with the sound waves that come from your voice box. The cell phone picks up those sound waves and converts them or translates them into invisible radio waves, those waves we can't see. Those radio waves have the ability to travel to the nearest cell tower, and they continue to bounce from cell tower to cell tower, depending on how far the person you want to call is. And once they get all the way to that person's cell phone, that person's cell phone then translates that radio wave back into sound waves so the person can hear exactly what you said. Next time you pick up a cell phone to call your grandma or your friend or your mom or whoever, you can picture the sound waves coming out from you, getting translated by your cell phone into invisible radio waves, which travel to the nearest cell tower. And depending on how far the person is that you want to talk to, it might bounce off multiple cell towers until it gets to the cell phone of the person you're trying to reach. Once those radio waves reach that cell phone then translates those radio waves back into sound waves so the other person can hear exactly what you wanted to say. During this lesson, you learned about how symbols, signals, and codes all communicate messages across long distances. The signal transfers a pattern, and that pattern is usually made up of light waves or sound waves, but sometimes those sound waves are translated into radio waves. I'll see you next time so that we can start to think, talk, and plan about how we might be able to use our own symbols, signals, and codes to communicate messages across long distances. I'll see you then.